Assalamualaikum. My name is SHAQEENA AINA, and today I would like to talk about capacitor and capacitance. To begin with, what is a capacitor? So a capacitor can be defined as the combinations of two capacitors placed close to another, and it is separated by an insulator. And a capacitor is very useful in storing electric charge and electrical energy that is stored inside of electrical components. So, have you guys ever wondered what's inside the capacitor, the small little electrical component? So, inside of a capacitor, it contains of two pieces of metal which are conducting materials, and it is separated one another. So inside of a capacitor, right, if we zoom in, this is what it will look like. So the two pieces of metal, it will create a distance or a small gap between it, and this small gap is called dielectric. So if we look into the diagram here, so the metals are connected with a battery. So the battery will give us a positive terminal and a negative terminal on each metal respectively. Note that the dielectric between the two here is to make sure that the metal pieces does not touch. So let us think what will happen if two pieces of metal connected is touched. If the two pieces of metal is touching one another, then both of the metals has no charges, as there is no charges ever get separated in the first place. Moving on to capacitance. Capacitance can be defined as the ability of a component or a circuit that connected is to collect and store energy in the form of an electric charge. Meaning that we want to know how good is a capacitance able to store charge. So a capacitor with a large capacitance can store a lot of charge. Meanwhile, a capacitor with a small capacitance will only store a small amount of charge. And this is the formula for capacitance. Capacitance equals charge stored and divided by the voltage or potential difference across the capacitor. That is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is HANNANI binti ABDUL JALIL, and today I will talk about combination of capacitors. There are two types of combination of capacitors, which are combination of capacitors in series and combination of capacitors in parallel. So first, I will explain about combination of capacitors in series. When capacitors are connected in series, the charge on each capacitor is the same. The total charge across the circuit is equal to Q1, Q2, and Q3. However, the potential difference across each capacitors are different. The total potential difference in the circuit is the sum up of potential difference on each capacitors, which means V total is equal to V1 plus V2 plus V3. For series circuits, the equivalent capacitance can be calculated by the formula 1 over C total equal to 1 over C1 plus 1 over C2 plus 1 over C3. So, I will proceed to explain about combination of capacitors in parallel. When capacitors are connected in parallel, the potential difference across each capacitor is the same. The total potential difference across the circuit is equal to V1, V2, and V3. However, the charge on each capacitors are different. The total charge in the circuit is the sum up of charge on each capacitors, which means Q total is equal to Q1 plus Q2 plus Q3. For parallel circuit, the equivalent capacitance can be calculated by the formula C total equal to C1 plus C2 plus C3. Next, I will discuss about example. From the question, 3 capacitors are connected as shown in figure. Question A asks for equivalent capacitance across AB. Question B asks for charge in C3 if the potential difference across AB is 6 volt. To solve this question, first we need to observe what circuit available in the figure. There are 2 ways to move across A to B. First, through C1 and C2, which makes a series circuit. Second, through C3, which makes a parallel between C1 and C2 with C3. Next, we need to know what combination of capacitors we need to use. In this question, we need to use both combination of capacitors. So first, we need to calculate the equivalent capacitance between C1 and C2. So from the formula, 1 over C12 equal to 1 over C1 plus 1 over C2. 1 over C12 equal to 1 over 150 times 10 to the power of negative 9 plus 1 over 200 times 10 the power of negative 9. So 1 over C12 is equal to 1.167 times 10 to the power of negative 7. So C12 is equal to 8.57 times 10 to the power of negative 8 farad. After obtaining the C12, we can calculate the equivalent capacitance across the circuit by using equivalent capacitance formula from combination of capacitors in parallel. So we need to sum up C12 with C3 to get C123, which is the value of equivalent capacitance across AB. So C123 is equal to C12 plus C3. C12 is 8.57 times 10 to the power of negative 8 farad plus 1 times 10 to the power of negative 7 farad. So C123 is equal to 1.857 times 10 to the power of negative 7 farad. For question B, the charge in C3 can be calculated using the formula Q equal to CV. We need to multiply C3, which is 1 times 10 to the power of negative 7 with potential difference, which is 6 volt. So the final answer will be 6 times 10 to the power of negative 7. If the question asks for Q total or Q123, it can be calculated by the same formula, which is Q equal to CV. Instead of using C3, you need to use C123 and multiply it with the potential difference given.
Hi and Assalamualaikum, my name is Iffah Fasihah, and in this video I will present about the electric energy storage. So what is electric energy storage? Electric energy storage is energy that is stored in a charged capacitor, and the symbol for the energy stored is the capital letter U. Energy stored in a capacitor is equal to the work done to charge it. As you can see, the energy stored in capacitor is given by equation U equal to half C times V squared, where C is capacitance and V is potential difference. But there is also another formula that can use for energy storage, which is U equal to half QV, where Q is equal to CV, and the unit for this formula is joule. Next, I will explain about energy density. Energy density is defined as the total amount of energy in a system per unit volume. So the symbol for the electric density is small u. The energy density formula is expressed as half permittivity times electric field squared, and the unit that used for this formula is joule per meter cube. In the next slide, there are some examples of questions from my subtopic. The first example is if the capacitance of capacitor is 50 farad charged to a potential of 100 volt, calculate the energy storage in it. So in this question, we have capacitor of capacitance of 50 farad that charged to a potential of 100 volt. The energy stored in a capacitor can be calculated by using the energy stored in capacitor formula. Substituting the values and we can get the answers. Don't forget the unit for this answer, which is joule. So the next question is to find the energy density of a capacitor if its electric field is equal to 5 volt per meter. Given that it is equal to 5 volts per meter, and we know that permittivity is equal to 8.85 times 10 to the power of negative 12. By using the formula given, we can substitute the information and we get the answer of the energy density. Also, don't forget the unit, which is joule per meter cube. So that's all for this subtopic. I will pass the next subtopic to the other presenter.
Hello everyone, my name is AQILAH and I'm ZAID. I will explain it on dielectric. So what is dielectric? Dielectric is an insulator. For dielectric can be characterized by K. So there are main purpose for dielectrics in capacitor. So it is to reduce field electric and to increase capacitance in capacitor. So it also allow QE to flow in bracket breakdown. Plate capacitor filled with dielectric can use formulas such as C equal to K epsilon A over T. So K is our constant, epsilon is our defined value, and A is the area and D is the distance. So for relationship of epsilon is E equal to K epsilon. That is the relationship for dielectrics. On more info about dielectrics, so I have mentioned about changing in electric field, which is reduced electric field. So by what I mean is changing in alignment of electric field between plates is opposing the original electric field between the plates on the original one rather than the new one. So that's what we call as reducing electric field in dielectrics. Other than that, the constant K that we have characterized in dielectrics can be varied their values depending on the material used. So dielectric also have their own strength. So this strength is referring to the maximum electric field that capacitance can endure before it breaking down. In this slide, I have put on two diagrams which refer to voltage increase and when we put the electrics, the capacitance increased by K.